We want to solve this system of equations. The first thing to note, saves us doing any work before we start doing algebra, is that none of these is just a multiple of the other. So we've got no parallel planes here. That doesn't guarantee we're going to get a unique solution, but it does make it worth starting to do the algebra. So let's call them 1, 2, and 3. Straight away I can see that I can eliminate z between 1 and 2 just by adding the equations. So if I do equation 1, add equation 2, that's 5x's and 2y's. The z's disappear, and if we add here we get negative 3. I'm going to call this equation 4. Now I need to get rid of z between two other equations. So if I do equation 2 and multiply it by 2, that gives me 6x plus 2y plus 2z is equal to 0. And then 3 was 4x plus 3y plus 2z is equal to 3. So if I now subtract these, I get rid of z. So that gives me 2x, take away y, is negative 3, and I'm going to call that 5. Now, 4 and 5, I'm going to try and get rid of y. So, equation 5 multiplied by 2 gives me 4x minus 2y is negative 6. And then 4 is 5x plus 2y is equal to negative 3. These are different signs, so if I add these equations, the y's will disappear. So 9x equals negative 9, giving me that x is negative 1. And now we can just work our way back up. X is negative 1, let's substitute that into 5. So 2 times negative 1, so that's going to be negative 2. I should say what I'm doing, sub in equation 5. Negative 2. Take away y is negative 3. Well, that gives me that y is equal to 1. Then go back to an original equation, such as 2. So we're going to sub everything into 2. X is negative 1, so that's going to give me negative 3. Y is 1, so plus 1. Add z is equal to 0. So negative 2 add z equals 0, gives me z equals 2. So in this case I got a unique solution. X is negative 1, y is 1, z is 2. Now we can do this on the calculator. So what we want is the simultaneous equations solver, and then what we have to do is just click here to get an extra line for the 3 equations. Then substitute them in. 2x plus y, take away z, is equal to negative 3. Now we want 3x, add y, add z, is equal to 0. And finally we've got 4x, add 3y, add 2z is equal to 3. And we need to tell it just here that we're solving for x, y, and z. Now that's not the answer I got before, but I've just noticed just here that the x didn't go in there. That's why it's always important to check what you've got on the calculator. And now I do get the same solution.